we have this problem that involves the manipulation of fractions. And of course, we are going to convert the mixed numbers to improper fractions first. So we take 2 and 2/3, and of course we are going to label the different numbers that we have involved in the fractions. We have the whole number, we have the numerator, and we have the denominator. Multiply the denominator by the whole number, then add the result to the numerator. So we are going to multiply the denominator by the whole number. 3 multiplied by 2 is equal to 6, and that we are going to add to the numerator. 6 plus 2 is equal to 8. The result is the numerator of the improper fraction. So 8 is the numerator of the improper fraction. And of course, the denominator is going to be the same as we had before. 1 and 1/5, we are going to do the same thing with 1 and 1/5. So we say 5 multiplied by 1 is equal to 5. Then we are going to add 1 to the result, which is, of course, we're going to add a numerator to the result, and we get 6. So the improper fraction will be 6 as the numerator, and of course the denominator will be the same. So we are going to do the same with 6 and 2/5. So we have 6 multiplied by 5. Of course, we are going to multiply the denominator by the whole number. 5 multiplied by 6, that is equal to 30. And of course, the result is added to the numerator, which is 2. So the result is 32. So we have 32/5 or 32 over 5. Then we will manipulate the fractions further. So let us add the fractions by making use of the common denominator. So we have this fraction here that is converted to this one, this converted to this one. And of course, instead of writing another fraction with another denominator and causing the expression to look too cumbersome for us to manage, let us write the fraction that we are dividing by, which is 6 and 2/5, that we have converted to 32 over 5. Let us say we are dividing by 32 over 5, which is what this line means. This line means that everything that we have up here is being divided by this. So let us proceed to divide. But we are going to add these fractions first by making use of the common denominator. Of course, the brackets are used right here in such a way that we realize that we are going to be adding the 8 over 3 to the 6 over 5 before we divide by 32. Without including the brackets, we will be saying that we are going to be dividing the 6 over 5 by the 32 over 5. And that will be an incorrect step. We need to include the brackets to indicate that we need to do this operation first. Of course, without the bracket, you know that division takes precedence over addition. So we would have done the division first. But we include the bracket to show that we are going to be adding these fractions first, which is, of course, if we are separating all of this from this, what we have in the numerator, the process that we have to complete in the numerator should be completed first. So the common denominator is 15, and of course 3 into 15 is 5, and 5 times 8 is 40. Then 5 into 15 is 3, and 3 times 6, 18. Of course, we are going to change this division sign to multiplication and invert this fraction. Of course, if we are dividing, an equivalent operation would be to multiply by the inverse. So dividing and multiplying by the inverse actually the same thing. And that we have done. So we have 40 plus 18 is 58 divided by 15, and of course 5 divided by 32. We may reduce 5 and 15, these two, by a common factor of 5, and we reduce 58 and 32 by a common factor of 2. So we will have 5 into 5 is 1, and 5 into 15 is 3. 2 into 58 is 29, and 2 into 32 is 16. 1 multiplied by 29 is 29, and 3 times 16 is 48. Now we are required to simplify this arithmetic expression that we have right here, and the result, we are going to have the result in standard form. So first we divide 0.0256 by 25 and see what we get. 0.001024, and then we are going to find the square root of 0.001024. The square root of that is 0.032, and that is going to be written in standard form. Remember that standard form requires that we have a single non-zero digit preceding the decimal point. By so doing, we would have been multiplying this expression by 1, 2. So by 10 to the power of 2, or by 100. So the result that we are going to write down must reflect an adjustment by. So in order to write this in standard form, we will be multiplying by 1, 2, 10 to the power of 2, or we will be multiplying by 100. Therefore, to return the number to its original form, we will have to divide by 100, which is the same thing as multiplying by 10 to the negative 2. So, in order to write this with one single non-zero digit in front of this decimal point, we will be adjusting this by 2 places of decimal. We need, therefore, to recover the original value of the number by dividing by 10 to the power of 2, or by multiplying by 10 to the power of negative 2. Now we have the basic wage earned by a truck driver for a 40-hour work week as $560, and we need to calculate the hourly rate. So we are going to find the hourly rate by dividing the amount earned for a 40-hour week by 40 in order to determine the hourly rate. For overtime work, the driver is paid 1.5 times the basic hourly rate. We need to calculate his overtime wage for 10 hours. That calculation can be made mentally. So let us do that. We need to find 1.5 times 14. So 1 times 14 is 14, and a half of 14 is 7. So 14 plus 7 is equal to 21. But we need the amount for 10 hours. So 21 multiplied by 10 is 210. So we have that as $210. And of course, we can do that on our calculator by saying we are going to multiply 14 by 1.5 and multiply the result by 10. But multiplication is commutative. So we may multiply all of these figures in any order that we choose. As long as we multiply 14 by 1.5 and also by 10. So, in this section, we need to calculate the total wages earned by the truck driver for a 55 hours work week. So, we need to calculate for what? 55 hours. If we are going to do that, then normal working hours will be 40 and the rest will be overtime. So, we need to make a distinction between the normal time and the overtime by subtracting the 40 from the total number of hours, because 40 is normal work hours and then the rest will be overtime. And when we do the subtraction, we get 15. Then the amount earned for the 40 hours of normal time will be the 40 multiplied by the normal rate. So the 40 multiplied by the normal rate is 560. And of course, it is the same thing that we have right here. And of course, the 15 hours that we have there, the 15 overtime hours, will be multiplied by 1.5 and also by the hourly rate. So we have 15 multiplied by the normal hourly rate, then we multiply that by the overtime rate, and the result is $315. At the end, we need to add the results, and we get $875. We need to factorize this quadratic expression. It is a quadratic because it is given in 4 terms, and of course 2 pairs of terms, and we may progress by using factorization by grouping. The common factor of the first pair is A. This is the first pair. The common factor is A, and of course A will cancel with A. We have 2x, and A into 3ay, the A will cancel, we have 3y. In the common factor of the second pair is B, and of course we are going to take the sign that begins the second pair, which is a negative sign, so we are going to have a negative B as the entire common factor right here. Negative B into negative 2bx, negative into negative is positive, the b's will cancel, we have 2x. And of course, negative into negative again, the b's will cancel also, and we have 3y, a positive 3y, because negative into negative is positive. So the common factor, as we can see, 2x plus 3y is in that bracket, and 2x plus 3y is in the other bracket. So the common factor is 2x plus 3y, and in the other bracket, what do we have? A minus b. Need also to factorize this expression, but the statement of the problem in CSEC is usually of the kind that says factorize completely. So if we take, as we can plainly see, that there's a common factor of 5, so we take that common factor of 5, we have 5 into 5x squared is x squared, and 5 into negative 20 is negative 4. some students would just move merrily on, but the statement of the problem is usually factorized completely. So we have a difference of 2 squares right there, so we are going to factorize this difference of 2 squares also. Here we have our favorite trinomial, and usually we say what two numbers multiply to give 3 times negative 15, which is negative 45. What two numbers multiply to give negative 45, and when we add them we get 4. The two numbers are positive 9 and negative 5. So we will have 3x squared plus 9x minus 5x minus 15. And of course, if some students choose to put the negative 5 before the positive 9x, then that's not going to be too much of a problem. The results will be the same. So we are going to take 3x as a common factor for these two pairs. Of course, we are going to do what? Factorization by grouping again. So we say 3x into 3x squared, we are left with x, and 3 will cancel with this 9, and of course the x's will cancel, so we have that. And of course, negative 5 into negative 5x, the 5's will cancel, and we have the x. Don't forget, negative into negative is positive, and 5 into 15 is 3. The common factor, as we can see, x plus 3 in both brackets, and what will go inside the other bracket? 3x minus 5. This time, as usual, as in recent years, we are going to be solving a pair of simultaneous equations that is given in the form of an applied problem. 1 packet of biscuits and 2 cups of ice cream cost $8, while 3 packets of biscuits and 1 cup of ice cream cost $9. What are we going to do? Multiply the cost of the biscuits by the number of biscuits, or the number of packets. So we have 1 packet and the cost is x. So that is 1x or x. And of course we have 2 cups of ice cream. So we have 2y. So it is x plus 2y is equal to 8. And the other one, 3 packets of biscuit, so 3x, and 1 cup of ice cream, so y, and that is equal to 9. And now we are required to solve the system of equations. We can see right here that we have 3x, so if we multiply this by 3, this equation by 3, we'll have 3x also. So if we multiply this equation by 3, we have 3x also. Also, we have y here. So if we multiply this equation, which is equation 2, by 2, we will get 2y. So if we are looking at the elimination process and we see that we can multiply either equation. But let's see what was done. Multiplying equation 1 by 3 will cause the coefficients of the x's to be the same. So we're going to multiply equation 1 by 3. So we have 3x plus 6y is equal to 24. That's what we have here. Just multiplying by 3. And that is equation 3. Now we have the coefficients of the x's being the same. We may eliminate the x's. So we have equation 3 minus equation 2. I think that is what we're going to say. With the coefficients of x being the same, we may subtract equation 2 from equation 3. So we're going to say equation 3 minus equation 2. What will happen? The x's will be eliminated. 6y minus y is 5y, and 24 minus 9 is 15. 5y is equal to 15. Y is equal to 3. And of course, we may place that value into any of the equations, and we are going to choose equation 1. So let's put that into equation 1. We have x plus 2y, and y is 3. So x plus 2 times 3 is equal to 8. And what is 2 times 3? 6. So x plus 6 is equal to 8. So x is equal to 8 minus 6, which is equal to 2. So one packet of biscuits cost $2 and one cup of ice cream cost $3. We have a Venn diagram, and we are going to complete the Venn diagram based on the information that we have. In a survey of 50 students, 23 owned cellular phones, 18 owned digital cameras, X owned cellular phones and digital cameras. 2X owned neither. So place the information in the intersection of the two sets first. And of course, X owned both of them. 23 owned cellular phones. And of course, we have X here already. So those unique to C will be 23 minus X. And on the other side, the situation is the same. 18 own digital cameras. And of course, we have X already. So right there, we have those unique to D will be 18 minus X. And do not forget that we have a set of students. We have a number of students who own neither cellular phones nor digital camera. So those will go inside of the Venn diagram, but outside of the circles that represent the sets that we have there. So we have 2x right there. An expression for the total number in the survey. We know that we have 50 of them, and the 50 of them will be all of these added. The one in this section added to this, added to the one in this section, and also here. So we have the number of in the survey will be the sum of the numbers in the different sections, and of course we know that is equal to 60. And not a surprise, we'll be required to find the value of x, and we are going to take a step further from this equation that we have here in order to find the value of x. So we transpose all numbers to the right hand side, and the x's are on the left hand side. The x's will be reduced to just x, and the right hand side will be reduced to 9. So x is equal to 9, and that's all there is to it. At this stage, we are going to do some construction. We are going to construct the rhombus that was given on the question paper. It was not drawn to scale, but we are required to draw it to scale. Let us construct the rhombus using the information that we have. So we are going to first draw the line PR, which is equal to 6 centimeters. PR is 6 centimeters. So we are going to draw that broken line PR 6 centimeters. PR. Next, we are going to construct the angle QPR equal 60 degrees. So QPR, the middle letter, will be the vertex where the angle is located. So we are going to construct that 60 degrees angle at P by placing the compass point at P and make arcs like that. Then we are going to place the compass point at the point of intersection of the line and the arc and draw another arc. So that angle that we have constructed, if we draw a line from P through the point of intersection of the arcs, will be 60 degrees. we are going to draw a construction line that should pass the point P when the diagram is completed. So there's our construction line. Right. If we are drawing a rhombus, the distance from P to the point Q must be the same distance from R to Q. We can make sure of that by constructing another 60 degrees angle at R. So each diagonal of a rhombus divides it into halves that are mirror images of each other. Let us construct a 60 degrees angle at R also. So compass point at R, make two arcs, and then remove the compass point to the point of intersection of the line and the arc, and then draw another arc, and then the 60 degrees angle at R would have been completed. Then we are going to draw the line through R. So the points of intersection of those two lines will be the point Q. We are going to construct the other half of the rhombus by putting the point of the compass at P and opening it with a pencil at Q. Then finally make an arc on the lower side of the triangle. So we're going to put the compass point right here. Open the compass, the pair of compasses, so that the pencil is here. Then make an arc down here. Also, we are going to place it at R and make another arc, that is without adjusting the pair of compasses, because we are sure that the distance from here to here is the same as the distance from here to here. So we can just go straight ahead without opening the pair of compasses between R and Q. If we open between R and Q, it is going to be the same thing as opening from P to Q. So we make another arc like that with the compass point at R, and then we complete the rhombus and have the point S right there. Draw the line QS as required. So that is QS, just going from Q to S, and we are going to measure the line segment QS. And of course we can see the beginning here, 10, 20, of course that is millimeter, so we can go to centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and of course a little less than half, so about 10.4 centimeters. That's what we have, 10.4 centimeters. The table shows two readings taken from an aircraft flight record. For the period of time between the two readings, calculate the distance traveled in kilometers. So we are going to find the distance traveled in kilometers. Of course, no problem. The distance traveled is the difference between the two recorded distances. So that is 126 kilometers. And of course, the period of time is the difference in time between the two readings. And of course, we can use our little common sense and say, if we are going from 8:55 to 9:07, we can go from 8:55 to 9 o'clock. And that will be 5 minutes. And then from 9 o'clock to 9:07, that will be another 7. So 5 plus 7 is equal to 12. Right? And that is what we have, 12 minutes. The speed is equal to distance divided by time. Now, the time that we have calculated is given in minutes, but the speed that we require is in the speed that we need is in kilometers per hour. So we are dividing 126 kilometers by 12 minutes. But of course, we need kilometers per hour, so we convert the minutes to hour by dividing by 60. So 26 to be divided by 12 over 60. And of course, if we are dividing by a fraction, it is the same as multiplying by the inverse or the reciprocal. So we have 126 multiplied by 60 over 12, and we are going to reduce the fraction by a common factor of 12. 12 into 12, 1, and 12 into 60 is 5. So 5 times 126. And of course, it is easy to multiply by 5. Multiplying by 5, you take half of this. Half of 12 is 6. Half of 6 is 3. Half of 6 is 3. 63. So the answer is 630 kilometers per hour. Measure the distance LM. Of course, we have a map, and the map is drawn to a scale of 1 to 50,000. And we are required to measure the length LM on the map. And LM turns out to be 7 centimeters. And do not forget that the scale of the map is 1 to 50,000. Next, we are required to calculate the actual distance in kilometers from L to M. So 1 to 50,000. So we need to multiply this by 50,000. So we multiply that by 50,000, we get 350,000, and of course that is going to be in centimeters. If we want that to be calculated to kilometers, we will have to divide that by 100,000. It is 100,000 centimeters that makes a kilometer. So this that we have there is still in centimeters. So we divide by 100,000 and we get 3.5 kilometers. If the distance between 2 points is 4.5 kilometers, calculate the number of centimeters that should be used to represent this distance on the map. Now, notice what we have here. We have an actual distance, and we are going to go to centimeters on the map. But before, we had centimeters on the map, and we wanted to go to actual distance. So all we have to do, use that 4.5 kilometers given to us and reverse the process. Divided by 100,000 here. So we multiply, if we are reversing the process, by 100,000. So we multiply 4.5 by 100,000, and of course that is equal to 450,000. And then we are going to convert that to the map. Remember when we converted the distance from the map to the actual distance, we multiplied by 50,000. Now we are going to be dividing by 50,000. So in an examination situation, we can just use our common sense to take advantage of a process that was required of us first. Right? In this particular case, we are just required to reverse the process, and that's all there is to it. However, if we so desire, we can take another approach. We have the 4.5 kilometers, and we are going to convert that to centimeters. To convert that to centimeters, we multiply by 100,000. Turns out to be the same thing. And then, do not forget that the scale on the map is 1 to 50,000. So we are going to be required to divide by 50,000. So dividing by 50,000, we get 9 centimeters. So either way, the problem is just as simple. We have here two functions, f of x equals 2x plus 5 and g of x equal x squared minus 31. Calculate f of 2. To find f of 2, we substitute 2 in the place of x in the function f. So where we see x, we put 2. So where we see x, we put 2. So we have f of 2 is 2 times 2 minus 5. And of course, 2 times 2 is 4 minus 5 is negative 1. F of 2 is equal to negative 1. We need to find g of f of 1. That's what we are going to find. G of f of 1. First, we find f of 1. When we find f of 1, we put that result into g. So, first find f of 1. What is f of 1? 2 times 1 minus 5. So, 2 times 1 minus 5 is negative 3. Now, we are going to put this negative 3 into g because we are finding g of f of 1. F of 1 is negative 3, so we find g of negative 3. So, g of negative 3 may be found by replacing x with negative 3 inside of that function g. So this is g, and we are going to replace x with negative 3. We have g of negative 3 is equal to negative 3 squared minus 31. And negative 3 squared is 9. 9 minus 31 is negative 22. Finally, find f inverse of negative 3. In order to find f inverse of negative 3, we need to find f inverse of x, or just f inverse. So, f inverse, of course, in Richard James Mathematics Resources, we have just learned how to look at it and write the answer down. First, we multiply by 2, then subtract 5. So in the reverse process, we are going to add 5 and then divide by 2. We reverse the operation and we reverse the order in which we perform the operation. So we multiply by 2 minus 5. So we are going to add 5, then divide by 2. So f inverse of x is x plus 5 divided by 2, all divided by 2. So f inverse of negative 3 just requires that we put negative 3 into this expression that we have right here. Not negative 3. F of 3 is equal to 3 plus 5 over 2, which is equal to 8 over 2, and that is equal to 4. This is one of our favorite because any question that requires us to do a graph on the examination is one that is going to afford us a lot of easy marks. First, we need to complete the table. That's not bad. We have 1, 2, 3, 4, 5, 6, 7 set of values in the table, and we are only required to calculate 2. I think that is more than generous of the examiners of CSEC. So, substitute the value negative 3 in the place of x. So we are going to have what? Instead of x, we have negative 3. Negative 3 squared plus 2 times negative 3 minus 3. And that is what we have right here. Then we square negative 3, we get a positive 9. Then we have a negative 6 and a negative 3. So when we simplify the result, we get 9 minus 6 minus 3 is equal to 0. And the 0 goes right there. And the other one that we need to find is where x is equal to 1. So substitute 1 into the expression. We have 1 squared plus 2 times 1 minus 3, and that is what we have right there. 1 squared is equal to 1. 2 times 1 is 2 minus 3. So we have 1 plus 2 minus 3, that is 0. Okay. Alright. So we are just required to calculate those two values that are equal to 0. That's not too harsh, is it? We are going to plot the points based on the information that we have in the table. So we have, first one, negative 4, 5. So negative 4 in the x direction and 5 in the positive y direction, and we put the point right there. Next we have negative 3, 0. Negative 3 in the x direction, no movement in the y direction, so the point is right there. Negative 2, 3, negative 2 in the x direction, negative 3 in the y direction, and the point is placed there. Then negative 1, negative 4, negative 1 in the x direction, negative 4 in the y direction, and the point is placed right there. Now we have no movement in the x direction and negative 3 for the y. So 3 units in the negative y direction. That's it. Then 1, 0. Of course, 1, positive 1 in the x direction, no movement in the y direction, and the point is placed there. Finally, what? The point 2, 5. 2 in the positive x direction and 5 in the positive y direction. That is what we have, and we are going to complete our curve by drawing a smooth curve through the points. And that's very nice. Now this one will prove to be a little bit more challenging, not because of its difficulty, but because it requires a lot of consideration of quite a few different things. But we'll see that we'll make light work of it nonetheless. We have 3 triangles there, right? And of course, the original triangle is A. Triangles B and D are transformations of A. And of course, we have the line y is equal to x, which is this line here. Y is equal to x because if you go here, 2, 2, the y value and the x value are equal. 4, 4, x value and y value are equal. And of course, that is going to be the same thing for all points on that line. The x value is equal to the y value, or the y value is equal to the x value. So we have that line as equation. Y is equal to x. So we're going to describe the single transformation, and we're not going to just describe it. We're going to describe it fully. Describe the transformation which maps triangle A onto triangle D. So let's see how A goes to D. Notice that triangle A and D are exactly alike. No shift, no. The only difference is that D is located at another position. So everything A and B are equal in all respect, with the exception that D is just at another location. And because of that, we say that the transformation is a translation. D is exactly as A, but at another location, it is a translation of A. And we can see that if we just take the triangle A and move it up, we'll get triangle D. See? Right. So choose a point on A and take a note of its motion in getting to D. So of course, we are going to choose this point here and see how it gets to there, which is of course the image of this point. So this vertex that we have here, the right angled vertex, is the one that we are looking at. So in getting from the diagram of A to the diagram of D, we move 1, 2, 3 places in the positive x direction, and then by 1, 2, 3, 4 units in the positive y direction. So it is a translation by the vector 3, 4. A and B have the same orientation. That means if we go like this on A to find naming the vertices, we are going in a clockwise direction. Naming the vertices of A, we are going to go in a clockwise direction, naming the vertices of the images of the points on A. Therefore, we are sure that because it is not what we call laterally inverted, so we are sure because it is not what we call laterally inverted, we are sure that it is not a reflection but a rotation. And in describing a rotation, we will have to find the angle of rotation. And of course, to find the angle of rotation, we need to take a look at the center of rotation. Now, corresponding points are equal distance from the origin. So we are sure, because the corresponding points on the object and its image are equal distance from the origin, we are sure that the origin is the center of rotation. And of course, the associated angle is equal to 90 degrees, going from A to B in a clockwise direction. So the transformation is a clockwise rotation through 90 degrees about the origin. Next, we need to state the coordinates of the images of the vertices of A if we reflect A in the line y is equal to x. So we are going to look at how we reflect in the line y is equal to x, and also we are going to take note of the vertices. If we are going to be doing a reflection, then what do we know? Each point will be located 90 degrees across the mirror line by the same distance as the original. That statement probably requires a little bit of decoding. Now, if we are going to locate the image of this vertex, we need to go across the mirror line in such a way that the line that goes across from this vertex to its image is perpendicular to the mirror line. And the point is going to be equal distance across there. The point that we are going to be locating is the point that is right here. And of course, we're going to write down the image of that vertex, which is, taking note of the coordinates, we go 3 in the positive x direction and 5 in the positive y direction. So that one is 3, 5. And we are going to do that for another vertex by going perpendicular to the mirror line and of course to the same distance on the other side. So we are going to take a look at that. 1 unit in the x direction, 5 units in the y direction. So that is 1, 5. Then the other point will go perpendicular again. We go across the mirror line, traveling perpendicular to the mirror line and the same distance from the mirror line as the original point. And we have 1 unit in the positive x and 2 units in the positive y. So we have 1, 2. So those are the vertices of the image of A if A were to be reflected in the line y is equal to x. Statistics require that we draw a graph in this question also, and of course we esteem graphs very highly in CSEC mathematics because we know that we can get a lot of marks right there. Now we are going to be ultimately join a cumulative frequency curve. But we need to complete the cumulative frequency column. So let's do that. Let us complete the cumulative frequency column. The present item in cumulative frequency column is added to the next item in the frequency. So we have what? This is the present one, and we are going to add this to the next one. So 22 plus 18 is equal to 40, goes there. And then 40 plus 22, 62, goes there. 60 plus 10, right there. And 72 plus 5, 77, that will go right there. And finally 77 plus 3, and that will give 80. The cumulative frequency curve is drawn by plotting cumulative frequency against upper class boundaries. For calculation of upper class boundaries, consult Volume 5 of Richard James Mathematics Resources, and that Volume 5 will be Computations 2 and Geometry. So, let us plot the points that we will use to draw the cumulative frequency curve. So we have 455, so not 55, we have 5.54, so we go 5.5 and then 4. We plot a point right there. We go then 10.5 and then go 11. Then we go 15.5 and all the way up to 22. Then 20.5 and we go up to 40. Then 25.5 and up to 62. 30.5, that's the one that we have next, and we go up to 72. Then 35.5 and we go up to 77. And finally, well, not quite finally, we go 40.5 and we go up to 80. Do not forget that in statistics, everything that is related to frequency will go on the vertical axis. Now, we cannot leave a curve hanging in the air, so we need to touch the axis, because if we just draw the smooth curve through these points, we will go right there and this curve will be hanging up there. So what we do is we cause the curve to touch the axis where the upper class boundary of the one previous to the first class would have been. And of course, we can see that we are going up by 5. If we are going down by 5, we are going to go from 5.5 to 0.5. So we will touch the time axis at 0.5, and then the smooth curve will be drawn like so. The median, we are of course finding the median. The median is associated with half of the total cumulative frequency. The total cumulative frequency in this case is not 90, although we have it labeled up to 90. If we go to the other slide where we calculated it, we'll realize that is 80 in the table, and of course the curve has a maximum height of 80. So we are sure that the total cumulative frequency is 80. Half of 80 is 40. So we locate 40 and draw a horizontal line to meet the curve. Then we draw a vertical line to meet the time axis. So that median time is equal to 20.5 minutes. And recently we realized that the examiners are giving total cumulative frequency to be equal to something other than 100, because some students have this programmed in their minds already that the total cumulative frequency must always be equal to 100. So as they say, find the median, students go to 50 and then go across, and then they end up getting the wrong answer, of course. So we need to be cognizant of the fact that total cumulative frequency is what we use, and half of the total cumulative frequency in this particular case is 40, the total being 80. So we need to go to 40 this time and not 50. Find the number that waited for more than 29 minutes. They waited for more than 29 minutes. So we find 29 minutes on the time axis and draw a vertical line to meet the curve. Then we draw a horizontal line to meet the cumulative frequency axis. And of course, when some students get 70, they just write down 70. But we are interested in those who waited for more than 29 minutes. So we are interested in above 70. And do not forget that when we are doing the part that goes above 70, we cannot go all the way up to 90 because the maximum is 80, because that is the total cumulative frequency. So this is the region that we are interested in. So how many from 70 to 80? Of course, 80 minus 70 is equal to 10. So we have 10 students. So we need to find now the probability that a student chosen at random from the group waited for more than 17 minutes. More than 17 minutes. So we go to 17 minutes and draw a line to meet the curve. Then what do we do? Draw a horizontal line. And what do we have? We are at 25, and we still need to be reminded that it is not 25 that we need. We need those who waited for more than 17 minutes. So more than will be the upper region. So we will have what? 25 from 80 is equal to 55, and of course the probability is found by dividing the number of those concerned by the total number. So that is going to be 55 over 80, and if we simplify that a bit, we get 11 over 16.